In this video, I'm going to talk about data modeling for SQL databases. First things first, as the name suggests, the database is a way to store data in an organized way so it can be used later in a website. SQL tables are basically tables with information related to each other. So what is data modeling? Data modeling is the way to plan and organize the data before creating the table. Usually that's done with an ER diagram, a diagram describing the different parts and relations in an abstract way before implementing them in a database. There are three levels of ER models: conceptual data model, logical data model, and physical data model. The conceptual data model is the least detailed one, while the physical data model is the most detailed one. There is a great example on the difference of levels of ER models on onekeyData.com. They use a simple product and sales database to illustrate how it's planned. The conceptual data model is used for overview of the main entities and relationships in a table. In this case, this is time, product, sales, and store. In the logical data model, all entities, relationships, foreign keys, and primary keys are added. Finally, all final details, like data types, are added in the physical data model. Now it contains enough information to create the actual database. The example I'm going to give is for a book club database, and I'll create a chance ER diagram for that. Chance notation uses rectangles to represent the entities, run by to represent the relationships, and ellipses to represent the attributes. The relevant parts are connected with lines, and the cardinality of the relationship is written on both sides of the relationship rhombus. Since this is a video for absolute beginners, I'll share a small trick my first database teacher taught me. To identify what entities, relationships, and attributes you need, write down a short paragraph describing the database. First of all, underline all the nouns. Then identify which ones will become entities and which ones will become attributes. Then underline all verbs and find the ones that regard the entities. These are going to be the relationships. So basically what I do now is I create the entities, which in this case are author, book, and member, and then the relationships between them. In this case, a book has an author, and the member owns a book. After that, I create the cardinality between the entities. A book can have one author, and one author can have many books. Also, a book can be owned by many members, and many members can own many books. Next, I add all the attributes: the author's first name and last name, the book's name and language, the member's username and email, and of course the IDs. The user ID, book ID, and author ID will be foreign keys and primary keys in the database. This means they will be used to connect the tables with joins later. Dia makes it very easy to define which key is a primary key and which key is a foreign key. Since there is a many-to-many relationship in this diagram, there will be another table needed. In this case, the owns relationship will be turned into a new table. That's why we also have to add attributes to the owns relationship. The attributes will actually be foreign keys: the user ID and the book ID. I also decided to add a number of copies owned by a member. And the ER diagram is ready. An alternative to chance notation is the Crawford's notation. You can find more information about it in the info box. Thank you for watching.